Our goal is to solve the equation log of the quantity x squared minus 5x plus 6 equals 0. By the end of this video, you will be able to solve logarithmic equations by converting them to exponential form and will be able to check for extraneous solutions. First, let's look at this equation. We have a logarithm on the left and a 0 on the right. A key concept here is the logarithm's base. The logarithm on its own, written as log, typically implies a base 10 logarithm. So our equation is equivalent to log base 10 of x squared minus 5x plus 6 equals 0. To solve this, we need to get rid of the logarithm. We do this by using the definition of a logarithm. The definition states that a logarithmic equation, written as log base b of a equals c, is equivalent to an exponential equation, which is b to the power of c equals a. In our equation, the base b is 10, the argument a is x squared minus 5x plus 6, and the result c is 0. Applying this conversion rule is the first big step. Now let's apply that rule to our specific equation. We have log base 10 of x squared minus 5x plus 6 equals 0. Converting this to exponential form means we take the base, 10, raise it to the power of the result, 0, and set it equal to the argument x squared minus 5x plus 6. So we get the equation 10 to the power of 0 equals x squared minus 5x plus 6. The next step is to simplify this. Remember that any non-zero number raised to the power of 0 is equal to 1. This is a crucial property of exponents. Therefore, 10 to the power of 0 is just 1. We have now successfully transformed our logarithmic equation into a much more familiar quadratic equation. 1 equals x squared minus 5x plus 6. Our task is now to solve this quadratic equation. The standard way to solve a quadratic is to set one side equal to 0. We have 1 equals x squared minus 5x plus 6. We can subtract 1 from both sides of the equation. This gives us 0 equals x squared minus 5x plus 5. Now, we have a quadratic equation in standard form. We can try to solve this by factoring. We are looking for two numbers that multiply to 5 and add to 5. The only integer factors of 5 are 1 and 5, or 1 and 5. Neither of these pairs adds up to 5. This tells us that this quadratic equation is not easily factorable using integers. When factoring doesn't work, our next best option is the quadratic formula. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4a, all divided by 2a, will give us our solutions. In our equation, x squared minus 5x plus 5 equals 0. The coefficients are a equals 1, b equals 5, and c equals 5. This is a crucial step to identify the correct values before plugging them in. Let's substitute our values of a, b, and c into the quadratic formula. Remember, a is 1, b is 5, and c is 5. Plugging these in, we get x equals negative 5 plus or minus the square root of negative 5 squared, minus 4 times 1 times 5, all divided by 2 times 1. Now let's simplify this step by step. Negative 5 is positive 5. Negative 5 squared is 25, and 4 times 1 times 5 is 20. The denominator is 2. Simplifying further, 25 minus 20 is 5. So we have x equals 5 plus or minus the square root of 5, all divided by 2. These are our two potential solutions. Let's call them x1 and x2. So we found our two possible solutions, but we're not done yet. When solving logarithmic equations, it is absolutely essential to check for extraneous solutions. An extraneous solution is a value for the variable that we find through correct algebraic steps, but which is not a valid solution to the original equation. In logarithmic equations, this happens when a solution would require us to take the logarithm of a non-positive number. Remember, you can only take the logarithm of a positive number. Therefore, our check is to make sure that for each of our solutions, x squared minus 5x plus 6 is greater than 0. Let's check the argument of the logarithm. It's the quadratic expression x squared minus 5x plus 6. This is a parabola that opens upwards. To be positive, the value of x must be outside its roots. Let's find those roots by setting the expression equal to 0 and factoring it. We need to find two numbers that multiply to 6 and add to 5. These numbers are 2 and 3. So x squared minus 5x plus 6 equals 0 factors into the quantity. X minus 2 times the quantity x minus 3 equals 0. This gives us two roots, x equals 2 and x equals 3. This means our argument, x squared minus 5x plus 6, is positive when x is less than 2, or when x is greater than 3. So, the valid domain for x is the interval from negative infinity to 2, or from 3 to positive infinity. We must confirm that our solutions fall into this valid range. This is the critical final step. Now let's take our two solutions and see if they are valid. Our solutions are x equals 5 plus the square root of 5 over 2 and x equals 5 minus the square root of 5 over 2. The square root of 5 is approximately 2.236. Let's use this value to approximate our solutions. The first solution, x1, is about 7.236 divided by 2, which is approximately 3.618. The second solution, x2, is about 2.764 divided by 2, which is approximately 1.382. Now let's compare these to our valid domain. X must be less than 2, or x must be greater than 3. Our first solution, 3.618, is clearly greater than 3. This solution is valid. Our second solution, 1.382, is clearly less than 2. This solution is also valid. Both of our solutions satisfy the domain restriction, so they are both legitimate answers. There are no extraneous solutions in this case. Let's quickly recap what we've accomplished and the steps we took to solve this problem. Our objective was to solve the logarithmic equation log of x squared minus 5x plus 6 equals 0. First, we converted the logarithmic equation into an exponential one. Second, we solved the resulting quadratic equation to find two potential solutions. And most importantly, third, we checked the domain of the original logarithm to ensure our solutions were valid, confirming they were not extraneous. This three-step process is crucial for solving these types of equations reliably. We found that the two valid solutions are x equals 5 plus or minus the square root of 5, all divided by 2. Thank you for watching.